So we're here to solve this Araf puzzle by Murat. It's fairly constrained in terms of where the regions can connect, and that's mostly from the geometry of the puzzle. It may not be obvious at the start, but these corner regions, when they connect out in certain ways, we'll sketch out some things that won't really matter. But imagine that 10 and 20 came together. If they came together this way, we'd isolate one clue on its own, which isn't possible. If it came this longer way, we'd isolate 5 clues, which is an odd number, is also not possible. Even if we do something like come over here to this 20, you'll have sort of 2 different scenarios for why like that's no good. This 8 can't connect to the 7 or 9, so it's forced to connect to the 20. Again, that's isolating 2 distinct regions in the grid, and that's because we're connecting border points, and when you connect border points, there's not room to go around in any direction, so once there's a barrier, very much we've isolated things. A different way to think about some of these connections, and this will end up being the more important part of this puzzle, is to recognize that when we have clues that are very close in size, you can sometimes choose a set of them or even color a set of them, maybe color is the better word, which will have to be distinct regions. Look at the 7s and 6s right now. There are 10 clues to the lower left of my pen. This 7, this 6, they can't be in the same region, so this is region 1, this is region 2, region 3, region 4, region 5, region 6. There are effectively 6 regions we know we need to draw if this were actually a way the puzzle split apart, because the 7s and 6s have to be in distinct regions. There are only 4 other region clues to connect with, so we need to draw 6 regions down here, but we're only drawing 5 regions down here. So this is an invalid way to split the grid because of how the 7s and 6s work. And at the start of the puzzle, there are actually these 4 7s and 3 8s or 3 6s, either the 7-8 group or the 7-6 group are interesting to look at. The other thing that's important in this geometry is to see that there are really 2 directions to get out of any of the quadrants. And these clues will need to be able to work together to get out. And so the place I started in solving this puzzle was to recognize that while clues like this 6 have some flexibility to get to some clues here, this 7 is nowhere near the clue it connects with. It can't connect to this 6, this 7, this 8, this 6, or this 8. It's got to get out of this quadrant, and it can get out of the quadrant a few ways. It could get out of the quadrant down here below, but let's say it came through and used this row. This 6 also has to escape. This 7 also has to escape. There are enough paths for the 7 to come out to the bottom and have the other clues work out. And so we don't really know the path it's going to take, but the 7 comes out to the top. This 6 may connect to this 8, or it may come out here, but in some sense, what we'll also know is this 7 here, it's not going to come up this way. If the 7 came up this way, it would isolate this 6. The 7 goes out that way, and so there's some star of the puzzle, which is something like this visually to see. Now let's think about what the 7 connects with, and in particular, actually let's not do what the 7 connects with. Let's start with what this 8 connects with. The 8 can't join to this 9, and if it comes out here like the 7, if it forms a path like this, to potentially get out, at least behind the 10 and 9 in this quadrant, which have to come together, which isn't possible. This is a short way of saying once you know the 7 comes up, you also actually know that the 10 and 9 come together, and they form a region of total size 9. We have to really grab these 9 cells just from this quadrant. We can't take this cell without leaving essentially this 9 a place to get out. And this 7 needs to at least take this cell if it to get up to this side. And so the shape of this 9 cells really is, if I mark this as unusable for it, its largest reach is effectively these 10 cells. It can't take this cell either. And every other cell that's in there is possible, but these 10 are the ones that matter. And if you recognize that you're not going to leave behind, say, this cell, which will be an unusual shape, we can get a starting shape like this, and we can even now really recognize that I think the 7 and 9 have to connect, and let's sort of talk through why that is. Where else can the 7 go? The 7 could potentially extend all the way to this 20. If it went to this 20, it isolates a clue if it goes over here. we get back to a situation we talked at the start where we have this 8-20 doing a 9-7 split, and 5, 6, 7, 8. It's too large to get to any other clue in the grid. So this 7 and this 9 come together. They're going to form an 8-cell long path, and that path has to only go to the right and up. It's got to be an efficient path. And so if it were to come and cheat over here, it would take too many cells to leave behind enough for this 9. And so I think the path you can draw by logic is what I have here. With these diagonal options, this cell and this cell are the ones that can potentially be used. These 8 are certainly part of this. And this is sort of the key starting point of this puzzle. It's a little hard to get it maybe, but with the 7 coming up, the 10 filling in, and then recognizing these 7, 9 come together, we get to here. We're going to come back now to what we said was the key thing in this particular Araf, which were consistent sets of clues that can't form the same regions. In 7 and 6, there are now 6 in the grid. There are a total of 12 clues. This is region 1, 2, 3, 4, 5, 6. And they're going to partner to a 20, an 8, an 8, a 9, a 20, and a 4. The constraint that's really key is after we recognize those are the 6 regions, there are 2 regions that have to join to 8s, and those 8s have to come with a 6 clue. And so this 8 on this side is a really, really tricky clue to connect with. It's got to come from a 6, and it can't come from this 6. It can't come from this 6. It has to come from this 6. And so at this stage in the puzzle, we can actually say there's a connection between R4C4 and R4C8. And that has to come up this way. It's going to be 7 total cells, so it's going to come over efficiently like so, and then however it joins, it will join there. This means at this stage that we actually know that the 7 and 20 come together. We know that this clue is going to actually come like this. That finishes this region shape. This 8 doesn't connect to the 9 or to the 7, so it comes down here. Once it takes this cell, and we know that the 7 takes these cells, the 6 and 8 have to be a pair. There's only one efficient way to take that. In Araf puzzles, we often have the shapes wrapped to the borders. This is exactly 7 cells. This 7-digit set now takes 7 cells, so we're going to actually see that it has to come over to the 20. That means the 6 and 4 connect. It means the 7 and 9 connect. So we have the connections. We now just have to think about how to fill in the spacing. The 7, 9 will need to take 8 total cells. Recognizing that the 6, 8's largest shape is like this, we sort of get an upper boundary like this, and recognizing that the 7, 20 shape may look like its longest shape is like this, there's kind of this 3x3 box. But this 6, 4 needs to take one more cell. It needs to be a total size of 5. And so while there is this 3x3 box to think about to grab 8 cells, we need to cheat in and take one corner to leave one more behind. If we took any other cell here for the 6, 4, we'd take too many to get around. And so the way that this works to leave behind 8 cells is to take all but one cell of the 3x3. This 6, 8 comes together efficiently like so, and that leaves behind just 8 cells as large as we need to get to fill this region. And we finish this Araf. I'll just draw the remaining boundaries to make it clear. This is a fairly tricky puzzle for a small puzzle, but it does come together by thinking through a set of the Araf constraints we've talked about throughout this week, recognizing clues that can't work together. The 7s really can't connect with 6s and 8s, and so at the start of the puzzle, one of the first steps is to see that we have one 7 that comes out through this channel, one that comes out through this channel, and then that gives enough options for the other 6s, but once we actually have these paths coming out this channel, you can identify that this 8 and 10 must join, this 7 and 9 must join, and then by looking at the remaining groups where we have 6 clues that have to be part of 6 distinct regions, and those regions themselves having connect to some of the 8s, this 6-8 connection is the real key in this puzzle. And once you identify that these must join, the rest of the puzzle becomes trivial, but it's a fairly subtle and important deduction to figure out why the 6 and 8 come together. So hopefully you learn a little bit about Araf from this talk through, and we'll see you again soon.